Hello and welcome to our final presentation for the APS360 project titled Cricket Match Winner Predictor. Today we're going to walk you through the entire process our team followed to create this predictor. First, let's start with introductions. I'm Krishna Sripada, an EC2T5.
I'm Snehal Sobti, also an EC2T5.
I'm Lianne Choong. I'm a Mag 2T5.
Unfortunately, Katarina will not be joining us today. We'll commence with a quick introduction to the sport, followed by the data collection process, and then we'll move on to the architecture of our model with a live demo. And at last, we'll show you the results obtained by the model. In simple terms, cricket is a game played on the field with a bat and a ball. Each team gets a chance to bat while the other team bowls, and the team accumulating the highest number of runs wins. Here are the multiple formats in which the sport can be played and the types of players present on the field at any given point of time, where the latter three belong to the bowling team. The sport is extremely popular across the world, with a fan base of about one-third the population of the world, with most of the fan base coming from the South Asian territories. For example, the Indian Premier League alone has a valuation of 3.2 billion US dollars. Among the three formats, we opted to use the one day international or the ODI format for our model. This choice was influenced by its practicality compared to test matches and its wealth of available data compared to T20 matches. In ODIs, each team consists of 11 players and they are constrained to over a 50 over limit per inning with a maximum of 10 wickets at their disposal. Now, let's talk about the process of predicting a game. This presents several challenges. Initially, the historical data is limited. Additionally, cricket's complexity, influenced by variables like pitch conditions, weather, and individual player performances, makes predicting outcomes difficult. Furthermore, cricket's inherent unpredictability, coupled with unforeseen match circumstances, amplifies the complexity. Constructing such a model can captivate a diverse spectrum of enthusiasts. This encompasses fans, teams, broadcasters, and analysts, each deriving distinct benefits to fulfill their unique requirements. Now I'll pass it over to Snehal.
So let's talk about data collection and data processing, which involves scraping, cleaning, and repurposing the data. So we have web scraped the data from a credible data source called ESPN Cricinfo, which has all the data for all available matches of ODIs, and we have collected data using the Pandas library and have converted the tables to Pandas data frames. And there are around 4,500 matches in total. To make this process of web scraping around 10 times faster, we have used multi-threading. Here is the structure of data that we have collected and saved in .xlsx files. We have data for bowling innings, batting innings, match results, and career stats. Next up is data cleaning and repurposing. First of all, we have synchronized the innings by innings and match results data frames. We have added match ID as the unique key identifier which connects both the data frames. But the problem that we were facing was that there were conflicting number of matches in both the data frames. So there were some data samples that were missing in one of the data frames. So we have deleted those incomplete records to properly align the match ID for both the data frames. Secondly, we have created a dictionary with key value pairs for faster lookup. We have used the player name as the key, and we have used an array of 9 features of that player as the value. So here is the final structure of data and the ground truth labels that we will input to our deep learning model. We are using a 198 element array as the input to our deep learning model, and there are 9 features for a player multiplied by 22 players involved in a match, which makes it a 198 element array. And we are using winner index as the ground truth labels for our model, 0 denoting that team 0 won, 1 denoting team 1 won, and 2 denoting no result. I will pass it on to Lianne.
So we'll talk about our deep learning model. The model we built is a 3-layer ANN, and we can see that the first layer inputs 22 by 9 and outputs 60. The second layer inputs 60 and outputs 20. The third layer inputs 20, and it's connected to 3 output neurons that tells you which team wins or if there's no results. So how does our data feed into our model? As mentioned before, there's 22 by 9 elements, consists of 2 teams, 11 player each, where each player is selected 9 different features. It's depending on the size, number of matches, the array size, the numbers, the values in the array are then normalized between 0 and 1. And through that, the data is then split into a ratio of 70, 15, 15, 15, and the data is then passed into our model. The outcome of our model is then validated through with our ground truth label. I'll then pass it on to Snehal.
So we will do a quick live demo.
So we will be doing two demos. In the first one, we will take team 0 as the stronger team and team 1 as the weaker team, and we will decide the player names on the basis of how many matches they have played. So let's start inputting experienced players in team 0 and unexperienced players in team 1. And as expected, team 0 wins against team 1, and that is predicted by a model. Now, in the demo 2, we will take the most recent ODI that happened on 27th July, and it was not involved in the training data for our model. So we input the player names for West Indies, which is team 0, and India, which is team 1. And our model predicts that team 1 should win. And let's check on ESPN Quick Info. And yes, team India won that match, and our model prediction is correct. And qualitatively, we can say that our model is good as it is performing well on never before seen data.
So we'll talk about our quantitative and qualitative results. Our team each tuned the hyperparameters of the model. You can see that each unique set of hyperparameters, it used different final training accuracy and final validation accuracy. The best set of hyperparameters use a final training accuracy of 0.854 and a final validation accuracy of 0.741. To qualify our model, we use the trained model with the best set of hyperparameters, which are 150 epochs, a learning rate of 0.01, and a batch size of 64, to test our model on never seen before data, and it used a final testing accuracy of 0.725. Thank you.